Um, Hi everyone.
Good afternoon.
Yeah, good afternoon. So it's very hot today. I wonder if you had Korean ginseng chicken soup.
I haven't actually.
Oh.
I should get one sometime this week.
Why not? Were you busy?
Oh yeah. Yeah, I was busy. I should get it like maybe in the weekends.
Weekends, like tomorrow?
Yeah, I'm thinking.
Okay. And you?
I had it last night.
Last night. That's nice. Okay. So today, if you learn the separable equation, you will be able to manage some big, massive chicken farm to feed you yourselves. So it'll be your modeling question for assignment. Okay, so let's start. Okay, so we're going to review what you learned like in last lesson. So we learned about order and linearity and homogeneity. So let's review. So, sorry. Oh, ah. You can tell the order of this equation.
Second one.
Second order, great, thank you. And how about this one? Excuse me. How about this one? Four, great. So we know what is order. Great. And how about linearity? Let me write some examples. Y squared is sine of t. Is this equation linear or not? No. Why? What term is the problem? First one, second one, third one. What's the problem? First one and the second one. They're all problem. And how about this example? Plus y e to the t. Is this equation linear or not?
Yeah.
Yeah, it's linear. Why is linear? Isn't this term problem?
No.
No. This is order.
Order.
Yeah. So we know what is linearity, and lastly we need to review the homogeneity. And yeah, let's go with the same one. Is it homogeneous or not?
I don't think it's homogeneous.
No. And you? Suhan? What?
Yeah.
Is it homogeneous?
Yeah.
Not really, because of this one. If you want to say an equation is homogeneous, you need to check if there is no t-only term. So if I write like this, it's homogeneous. Well, it's not linear, but it's homogeneous, yeah. And let's check this one. Plus y equals. How about this one? Is it homogeneous or not?
It is.
It is, right. And we don't really need to think about this t, right? Yeah. So we reviewed the types of differential equations, and additionally we need some integration methods. As you all know, we need to integrate to solve differential equations. Yeah. So we need another example. For integration by substitution or use substitution, we can do, oh, sorry. 2 times x times e to the x squared and dx. We can do this. Would you write it down here? Thank
The
you.
whole process?
Yeah, you can do that if you want to. Or you can just write answer. Great. Oh, okay. Okay.
UV minus T.
Oh, you can use substitution, not integration by parts. Okay, we'll do that. Oh, sorry, I erased everything. Would you try again?
par츠를 했구나.
Yeah. Nice.
오케이.
Okay. Okay, thank you. Let's see.
Let's see.
Yeah.
Yes, 그 정도 보면.
That's right. Yeah. You did it right. Thank you. Great job. U equals x squared, and you simply differentiated this one. So, yeah, there's nothing to say. Yeah. Thank you. And how about integration by parts? The common example for this one is integration of logarithm. It's quite technical, so let me do this. You can write 1 here and do the rest. Actually, we need to do it like this. So we differentiate this one and leave it alone, and oh no. Oh. So we need to different. Huh?
No.
Sorry about that. We need to integrate this one and differentiate this one and integrate this one. Yep, so minus 1 dx is x. So yeah, we can just, let's see. Thank you. That is integration by parts. Is there any question about integration methods? Not really. So now we can move on to today's topic. What is a separable equation? So if you can make any equation into this form, you can simply separate by multiplying fy dx to each side, and you can see, f of y dy equals to my mistake. This is t. Is g of t and dt. as you can see, the variables are separated. This side is y only side, and this side is t only side. That is why we call this equation is separable, or we call this method as solving an equation with the separation of variable. Okay.
Oh yeah, so I have a question. So when I started learning easy calculus
Yeah,
a few
okay.
years back, my calculus teacher always said that dy dx,
Oh.
dx dt, these signs were conventional.
True.
But obviously it looks like a fraction, right?
Yeah, true. That's also true.
But when students ask if it is a fraction or not,
Mhm.
then the teacher said that it is not a fraction.
Yeah,
but
it's
it's
not.
conventional way to write it that way. But
Mhm.
now, learning, differential equations like separable equations, we are manipulating that sign as if
As
we're
a-
treating
yeah,
it as such.
fraction.
So I'm curious if it is a fraction or not.
Ooh, well, to answer that, first of all, it is not fraction, and these thing means very small variation of y and x or t, respectively. If you want to deal with these symbols seriously, you need to learn differential forms in university. But now, even if it's not fraction, not real fraction, we will use these thing as fraction. It's just to solve the differential equation more conveniently. That's all. It's not really, it's not that deep.
So you're saying it's still legal to
Yes.
treat it as a fraction?
Yeah, right. The reason, you'll learn the reason if you go to university
Uh-huh.
and take some serious math lectures.
Oh, thank you very much.
Yep. So, we'll have some examples for separable equations. Well, we can see that you can just integrate this, but not really, but you can see this equation is separable, so we will just practice how to use separation of variable methods to solve differential equations. So we can multiply 2y dt to each side. 2y and dt. And you can integrate each side equals y squared is t plus c. And if someone gives you initial value, like y0 is, let's go with 0. Then you can get y squared is t, and y is plus minus square root of t. Let's draw something. You can see that, right? First of all, the solution doesn't tell anything about negative t. So if you want to tell something about negative t, but your solution doesn't give any information in that interval, you did it wrong. So you need to check to fix something. So, and something came worse in this example. Let's talk about 0, 0. And you can see that we cannot tell the gradient here because the tangent here is vertical. So yeah, we cannot tell information about t equals 0. Like, to be clear, like the gradient at t equals 0. And lastly, you cannot even tell which side will this solution move. Let's say someone gave you like y1 is 1, then it will give c equals 0. However, since you have 1, 1 here, you can say that the solution comes from here and it goes to here, not this one. But if you have this one as your initial value, you cannot tell. The solution is not that unique, so you need to be careful whenever you solve differential equations. Okay, so we will move on to the example 2. So that's example 2, and it seems quite difficult, right?
Yeah.
Yeah, or not?
Yeah.
Oh, okay. But it's not that difficult. You can do this. First of all, if you multiply dx to each side, you can easily separate any variables in this equation. So if I rewrite this, e to the y dy is 2 times x plus 1 and dx. And you can integrate. The y is x squared plus x plus c. Well, you could just put this initial value in and get the c. And e to the 1 equals 1 plus 1 plus c. Okay, so c is e minus 2. Thank you. And now, to solve this, c was e minus 2, and you can take logarithm of the whole thing, and this will be y,
Yep.
and x squared plus x plus e minus 2. Quite simple, right? Okay, so now we'll talk about the population model. It can be used to model ecological populations or human populations, or, as I told you, the number of chicken in your chicken farm. Yeah. So it will be your modeling question, but we'll deal with the population model first.